Hello everyone, this is Rohit Raj and today I'm going to be talking about assembler. So assembler, I'll be showing a small simulation of how the assembler gives the output, how the assembler takes the input and gives the output. So this was given as a experiment, sixth experiment for our system software in Compiler Lab. So basically, what assembler does is it takes the file, it takes the opcodes and from generated in assembly language, and then it converts it into the machine language. It converts it into the machine executable form, and then the rest of the work is done by the machine. So this is the algorithm on how the assembler works. First, we open the file, then it starts. The opcode starts reading the input when the start command is given, and it initializes LC to get to set the addresses and to input the addresses in system table and whatnot. Uh, and this process is repeated. So, this is phase one. In the phase one, what happens is it searches for the identifiers that are not there in the symbol table, adds them. If this identifier is already added in the symbol table, it skips that and moves along. That's how the phase one works. And in the phase two, that opcodes are compared with the actual uh, what is the opcode number or mnemonics, and that are given as the output to the machine. So I'll be showing a demonstration on how this is done. This is my project folder file. Here I have the program in program.txt file. So this is the program. It has a start command and an end command, everything. And the opt this I gave this to show what's the mnemonic for a particular opcode. This contains the mnemonics for the particular opcode. For the following program, these are the only three opcodes present. So I just gave the three to simplify the work process. And so this program I actually I didn't write this program. I just I gathered this from different various sources and made it into one part. None of this program has actually been written by me, but I understood this program enough to show you how this works. So for the main thing, we'll be taking the following. We'll be inputting the following classes for our work to done. Most of them are like common classes like buffer writer, file writer, IO exceptions. The only new thing you might see is hash table. So in the first thing, we create necessary objects for the given classes, and then we read the program. When they read the program from program.txt file, and we start the output. We start the output to a.output.text. We set the output. We set the what we call that the seeker to 0 and make it ready for writing. And then we read the we read line by line from when start function like from when the start opcode appears in the program, and then we split them according to the need, and then set them into the symbol table until n comes. So until n comes, this process keeps on repeating. Then unknown identifiers are set into the table, and we update the symbol table all the time. We pass the values like line number, opcode, what is this that what is the symbol, what is the address, and where it is. So once that completes, we set that to a.output file, and then we convert the address into hexadecimal. So converting into the hexadecimal automatically gives the required address into the output file. And then we compare the symbols with the with the octave here, and then change the values accordingly along with the address. These high this upper arrow here is uh, for user recognition. Actually, the machine doesn't give this as an output. It has a continuous sequence of numbers and addresses. This is for user identification, that these are two different works that are happening over here. So let me run this program. So it takes this program and converts it to this following assembly output. As you can see over here, this is the header file, that is the start file, and what's the name of the function. So what's the name of the program? So copy is the name of the program. It doesn't change, and from then we get the values. From then we get the mnemonics and the address, and this is actually the actual program. This is the starting address of the program. So the mnemonic and its address value, and its length, and then its address value. So this is my compiler lab experiment 6 assembler. Thank you.